Alright, in this video I'm going to walk through the moles test review. And the first question asks, what is the percent composition of sodium phosphate? So we're going to figure out what the percent sodium, the percent phosphorus, and the percent oxygen are. Now, to find the percent sodium, we're going to take the mass of sodium, which is 22.99, times 3, divided by, well, now we need to figure out how much this entire compound weighs. So we're going to take the mass of sodium times 3 plus the mass of phosphorus plus the mass of oxygen times 4. And that's 163.94. So to find the percent sodium, we'll divide that by 163.94, and to make it a percent, times 100. So 22.99 times 3 over 163.94 times 100. So it's 42.07% sodium. We're going to do the same thing for phosphorus. And for oxygen, making sure that we multiply the mass of oxygen by 4. And when we do that, we get 18.89% phosphorus and 39.03% oxygen. All right, for problem number 2, this is an empirical formula problem. So we're going to take our percents and we're going to write them down as grams. So it's going to be 40 grams of carbon, 6.6 grams of hydrogen, 53.4 grams of oxygen. We're going to take those grams and we're going to do a one-step mole conversion to turn them into moles. So we'll run those calculations real quick. And we get that we have 3.33 grams of carbon, or moles of carbon, 6.56 moles of hydrogen, and 3.33 moles of oxygen. The next step is to divide by whichever one of these numbers is the smallest, which is 3.33. And so if we take 6.55 divided by 3.33, we got 1.97, which is basically 2. So our empirical formula is CH2O. For number 3, it says if the actual mass of vinegar, which is the thing we were working with in number 2, is 60 grams per mole, what's the molecular formula? So this was our empirical formula. Now, what we need to do is figure out, does CH2O have a mass of 60? So let's take the mass of carbon plus the mass of hydrogen times 2 plus the mass of oxygen, and it has a mass of 30. The molar mass is 30 grams per mole, which is not 60. So if we take 60 divided by 30, we get the actual compound is twice as heavy. So the actual compound, instead of CH2O, the molecular formula is going to be twice that much. C2H4O2 is the molecular formula. Problem 4 works very similarly. We take our percents and write them as grams. We then take our grams and turn them into moles. Using the numbers off the periodic table. And we'll multiply those out. We get 1.41 and 3.52. So we then divide by the smallest number of moles. And 3.52 divided by 1.41 is 2.49 or 2.5. So this is where we don't get whole numbers after this step. So now we need to take everything and double it. So our empirical formula is going to be P2O5. Now, it says that it has a molar mass of 283.88. So does P2O5, that's our empirical formula, have a mass of 283.88? Let's take the mass of phosphorus times 2 plus the mass of oxygen times 5. This has a mass of 141.94. So if we take 283.88 divided by that, we get 2. So the actual formula is twice as heavy as this. P4O10 is the molecular formula. In problem 5, it's just asking us what's the molar mass of this compound. So we take the mass of calcium off the periodic table, times 5, plus the mass of phosphorus times 3, plus the mass of oxygen times 12, plus the mass of fluorine. And when you punch that in, you have 504.31 grams per mole. Number 6, it wants to know how many moles of CO2 TiO4 are in 7.13 grams of the compound. So we're starting with 7.13 grams, and we're trying to go from grams to moles. The number that goes with moles is 1. Grams goes on the bottom because we started with grams. And then to find the number that goes down here, we need to add up the mass of 2 cobalts plus the mass of titanium, which is 47.87, plus the mass of oxygen times 4, which is 229.73. So we take 7.13 times 1 over, that number is 0.031 moles. Number 7, it wants to know how many molecules are 3.2 grams of NF3. Well, we need to take our grams of NF3 and turn them into moles. And then we need to take our moles and get all the way to molecules. The number that goes with moles is 1. For grams, we need to take the mass of nitrogen plus the mass of fluorine times 3. That's 71.01. And then for molecules, we're going to use Avogadro's number off the front of our reference tables. And then we'll put that in our calculator. 3.2 times 1 over 71.01 times 6.022 times 10 to the 23rd over 1. It gives us an answer of 2.71 times 10 to the 22nd molecules. In number 8, it wants to know how many grams of mercury are in 1.19 times 10 to the 23rd atoms. So we start with 1.19 times 10 to the 23rd atoms. And in our first step, atoms will go in the denominator. And we can go from atoms to moles. And then it wants to know grams, so we need to go one step further to go from moles to grams. So 1 mole is Avogadro's number of atoms, and 1 mole is, for mercury, which is Hg, 200.59 grams. So we do 1.19 times 10 to the 23rd times 1 over 6.022 times 10 to the 23rd times 200.59 over 1. And I'm getting 4.07 grams of mercury. Problem number 9 works very similar. We're starting with 1.13 times 10 to the 23rd molecules of CO2. And we need to go from molecules of CO2 to moles of CO2. And then it wants our answer in, it wants mass, so we need grams. So we need to go from moles of CO2 to grams of CO2. The number with moles is 1. Molecules is Avogadro's number. And then for grams, we need to take the mass of carbon, 12.01, plus the mass of oxygen, which is 16, times 2, so that's 44.01. Then to put this in the calculator, we do 1.13 times 10 to the 23rd times 1 over 6.022 times 10 to the 23rd times 44.01 over 1. And we get 8.26 grams of CO2. For problem number 10, we're starting with 350 grams of KClO3. And it wants to know how many moles. So we're just going from grams to moles. That's a single step, just like in our empirical formula calculations, where 1 mole equals the mass of potassium, 39.1, plus the mass of chlorine, plus the mass of oxygen times 3, which is 122.55. So we plug this into our calculator and we get 2.86 moles. Then this brings us to problem 11. Works very similar. If we have 166 grams of calcium chloride and it wants to know how many moles, we're going from grams to moles. We take the mass of calcium plus the mass of chlorine times 2. It's 110.98. So 166 times 1 over 110.98 is 1.50 moles. For problem number 12, we're starting with 40 grams of TiO2, and it wants to know how many formula units. Well, formula units are very similar to molecules. It's just for ionic compounds, but we'll treat it the same way. But since we start with grams, grams goes on the bottom, moles on top, and then it wants formula units, so moles will go on the bottom and formula units on top. 1 goes with moles. For our grams, we take the mass of titanium plus the mass of oxygen times 2, which is 79.87. And then for formula units, which is a type of particle, Avogadro's number. So we multiply 40 times 1 over 79.87 times 6.022 times 10 to the 23rd over 1. And we get 3.02 times 10 to the 23rd. Don't forget that part. Formula units. In problem 13, this wants to know what's the percent nitrogen in NH420. That's similar to this percent composition problem up there, but all we're asking for is the percent nitrogen. So we take the mass of nitrogen, which is 14.01, times 2, because there's 2 of them, divided by the mass of the whole compound times 100. So we need to take, for the whole compound, it's the mass of nitrogen times 2 plus the mass of hydrogen times 8 plus the mass of oxygen. So 52.084. Then plug this into our calculator. And we get 53.8% nitrogen. Problem 14, very similar. So we're going to find a percent copper, a percent sulfur, and a percent oxygen. So we're going to take the mass of copper divided by the mass of the whole thing, the mass of sulfur, 32.07, divided by the mass of the whole thing, and the mass of oxygen times 4 over the mass of the whole thing, times 100. And so our denominator here is going to be the mass of copper plus the mass of sulfur plus the mass of oxygen times 4. That's 159.62. And when we work all that out, we end up getting 39.81% copper, 20.09% sulfur, and 40.1% oxygen. Problem 15 is an empirical formula problem. So this is where, once again, we take our percents and write them as grams. And then we do a one-step mole conversion to turn our grams into moles. And then when we calculate this, we get 1.06 moles of nitrogen, 3.17 moles of oxygen, and 0.53 moles of zinc. So now we divide by the smallest number, 0.53. And we'll get 1 for zinc, we'll get 2 for nitrogen, and we get 5.98, essentially 6 for oxygen. So our formula is N2O6Zn. For number 16, similar process. We're starting with 24 grams of carbon, 76 grams of fluorine. We'll turn our grams into moles. And we get 2 and 4. Now don't forget, we now divide by the smallest number. So the empirical formula is CF2, 1 carbon, 2 fluorines. Now this tells us the actual compound has a molar mass of 200. Now for CF2, we take the mass of 1 carbon plus 2 fluorines. This has a mass of 50. The actual compound weighs 200. So it's 4 times heavier because 200 divided by 50 is 4. So the molecular formula is 4 times this amount, or C4F8. Problem 17 works very similar to that, where we take our percents and write them down as grams. And then we'll turn our grams into moles.